Hello and welcome to CommsVerse. This is session 262, titled Microsoft Teams Optimization on VDI Platforms. I am pleased to introduce our presenter, Alex Ivanov.
Thank you, Mary, and thank you everyone for joining my session. And so my name is Alex Ivanov, and I'm working at Microsoft Teams product group, and my primary focus is quality of new Teams features. I live in Minnesota, US Central Time Zone. Minnesota is a great place. We have two seasons. We have cold winters and hot summers. We also got mosquitoes, which makes summers really fun. Today, I'm really excited to share with you what we have been working on in VDI space. And we'll talk about Teams on virtual desktop infrastructure. In my presentation in this session, I will go over general solution architecture, supported VDI platforms, and features available on VDI. I will do deep dive on media optimization for calling in meetings and cover best practices and recommendations for deploying Teams in VDI environments. I also will do a demo so you can get an idea about Teams on VDI experience. So if you join my session, you probably heard about VDI. And for those of you who are not familiar with VDI, I will give a short overview. So basically, virtual desktop infrastructure, VDI for short, is virtualization technology that hosts desktop operating system and applications on centralized servers in a data center. This enables fully personalized desktop experience to users with a fully secured and compliant centralized source. Early last year, we released support for Microsoft Teams in virtualized environment for chat and collaboration modalities. In the end of last year, December 2019 exactly, we released in partnership with Citrix support for Teams media optimization for call-in and meetings on Citrix VDI. And last month, we released in public preview support for Teams call-in and meetings optimization on Azure WVD, Windows Virtual Desktop Platform. We are also working in a very close partnership with VMware to deliver Teams media optimization on their VDI platform, and are close to getting it ready for our customers. As we constantly improve in Microsoft Teams in general, we are also continue development for Teams on VDI and are adding new features and functionality regularly. So here is how the solution architecture looks like. Let's start with a virtual machine on the right. Let me get my pointer. So here we have virtual machine, and here we have a client. So the virtual machine is the VDI host with the software components from VDI partner. VDI partner components on this diagram are highlighted in green. Here we have a VM process. It is a WebSocket service responsible for communication between VDI backend and VDI client. Also here we have media stack. It is WebRTC media stack that gets engaged when it is detected that client is running in VDI environment. This is controlled by optimization settings configuration in VDI partner suite and presented as a registry key entry. We also have VDI shim. It's loaded from Office 365 web services and runs as a JavaScript code in Teams client. The shim is maintained by VDI partner. Shim is a JavaScript in Teams that connects to WebSocket and sends receive media commands to VM process. The WebSocket server then relays information to and from VDI client. On the client machine, we have only VDI partner client. That could be Citrix Workspace app, CWA in short. It could be WVD Remote Desktop, or it could be VMware Horizon client. This needs to be a specific version of VDI software to support optimization. We recommend to have latest and greatest version for VDI software, so your users have the best experience and latest features with Teams on VDI. All content not related to audio and video is executed on VDI host on the backend, communicating directly to Teams services in the cloud. When VDI optimization support detected on Teams launch, instead of loading native Slim Core media stack, we load WebRTC media stack and VDI JavaScript code. The shim will establish a local connection to WebSocket on the local port 9002. This VM process will leverage VDI partner signaling to communicate events to a process on the client machine. When the call is attempted, WebRTC stack on the client will allocate media devices, negotiate SDP, and connect the media. Events with video element position will flow from Teams client on VM host to the VDI client. VDI client on user machine will be aware of the video position that should be rendered and will draw the video frames locally while overlaying video over Teams client rendering on VDI host. In the case of pop-ups like contact card or notification toast, events with windows in front of Teams on VDI will flow from VDI host to VDI client, so client can execute an occlusion of the video. And audio playback will be executed on the client machine via local device, audio devices like headset plugged in a client machine USB port. I included a couple screenshots to give you example of occlusion. You can see here contact card which is displayed on VDI host, and information about this contact card and its location communicated to VDI client. In this case, VDI client basically cutting out opening in overlaying video to show contact card from backend to the client, on the client to the user. This is another example of occlusion principle, but applied to pop-up element, including Windows notification or Teams toast. You can see that there is the same idea that we get a client gets information about location of this pop-up, and then video occlusion is created to show this pop-up. For VDI implementation, we choose WebRTC as our media stack. We are also using WebRTC for browser-based web clients. The WebRTC client, WebRTC project is open source and supported by Apple, Google, Microsoft, and Mozilla, and other industry players. With WebRTC, you can add real-time communication capabilities to your applications that works on top of open standard. WebRTC supports video, voice, and generic data to be sent between peers, allowing developers to build powerful voice and video communication solutions. Our goal was to create a performant VDI implementation that will work seamlessly with multiple platform partners. We took approach to augment Teams by injecting functionality to allow audio-video to be remoted. For example, WebRTC function override creates the connection on the sync client instead of VM, allowing audio and video to stream directly between the remote client and a VM host and the sync client. Mirrored AV elements allow changes in Teams running on VM host to be represented on a sync client. And a partner VM implementation contains secure connection to the sync client, allowing VM host to be notified about audio-video events on the sync client. WebRTC enables us to introduce new features and functionality across the board on multiple platforms at the same time. It also creates simplified entry point for other platform vendors. Now let's talk about optimization and what does it mean as this core concept we need to have a good grasp with. On a one-to-one multi-point call, Teams signaling will flow through the Teams cloud service. For media, Teams will use ICE protocol to attempt to locate direct paths between two endpoints. Let's see what would happen if we introduce VDI into picture. So just adding VDI component will make flow more complex. You can see that Teams is running on VM host that in practical terms will be the endpoint. So you can see there are two big challenges. One, without optimization in place, media will flow between users using suboptimal paths and protocols. And second issue is VM host will be encoding and decoding video, which means there will be higher demand for limited back-end resources. There are also other challenges, but those are two biggest negative effects on user experience. With the peer-to-peer call, when Teams is not optimized, media will be pushed from client machine to VDI host, processed there, consuming networking and backend hardware resources, and then relayed to other VDI hosts, where it will be again processed, and then we will get the whole trombone effect, and this introduces multiple hops, additional latency, and puts strain on limited VDI infrastructure and networking resources. With optimization enabled, media will flow directly between two endpoints, and the media processing offloaded to client endpoint. There are several other functions moving from VM host to VDI endpoint. Those functions would be create a candidate for SDP, allocate and enumerate audio and video devices like webcam and microphone and speaker and desktop content when sharing, encode and decode media, render audio and video locally. As you can see with Teams optimization, media is flowing directly from point to point and processed locally on a client machine. As a result, audio and video quality is much better and users get much better experience. In case of conferencing, when Teams is not optimized, media would be pushed from client machine to VDI host. Then it has to be processed there, again consuming networking and hardware resources on the back end. And then it should be relayed to the Teams conferencing service in the cloud via corporate internet connection. This introduces multiple hops, additional latency, additional resource constraints, and puts strain on limited resources. With Teams VDI optimization, audio and video and screen sharing will be flowing directly from VDI endpoint to the Teams conferencing service and back directly again, which means that users have much better audio and video quality, and experience is so much better. So let's summarize benefits of Teams media optimization on VDI. First is a local media processing, which means that there are no resources used on a backend infrastructure to process resource-intensive media workloads like video and desktop screen share. It also means that corporate network edge resources are not involved, so there is no inspection and managing traffic, which usually introduce additional friction, even if properly managed or configured. And then there are benefits of direct media, which means that in case of peer-to-peer call, media flows directly between two endpoints, and that leads to improved audio and video quality due to decreased latency and decreased number of hops and decreased processing required. Same benefits apply for conferencing scenario, when audio and video media is flowing directly to Office 365 conferencing service in the cloud without traversing your company network and with less hops. And we are avoiding trombone effect, where all media is pushed to the backend processor and then relayed to the back of VDI client or to the peer or conferencing service. Now that we covered architecture and general principles behind the solution, let's talk about how to deploy Teams in VDI environment. We had a lot of customer feedback and requests to create special Teams package for VDI environments and allow administrators to control and manually manage client deployments and updates. Based on feedback and customer requests, we built Teams MSI package, and we created documentation with deployment guidance for VDI. For Teams deployment in VDI environment, we recommend to use MSI client version and deploy Teams MSI client as part of VDI image. If Teams client was previously installed as EXE or MSI or part of Office Pro Plus, it must be uninstalled first. Then you would need to download latest MSI bits and deploy Teams MSI client using per machine mode. The attribute all user equal of 1, again, it's all user, there is no S in the end. It's a special VDI specific attribute. So all user equal 1 defines per machine deployment mode. When Teams installed in the per machine mode, the client is deployed under program files and auto updates are disabled, which means that VDI admins need to periodically download latest version of MSI package and update Teams MSI client in the VDI image to make sure that client version is not stale and VDI users are getting new features, bug fixes, and the best experience with Teams on VDI. When the new Teams MSI client version is available, VDI administrator would need to follow steps outlined on this slide and uninstall old MSI version, and then deploy new MSI client version of Teams into their golden image. I would like to highlight best practices that we learned during feature validation in Teams tab, and I highly recommend to follow for our VDI customers. For the best experience with Microsoft Teams on VDI environment, we recommend to deploy MSI client version in per machine mode. With per machine mode, we also implemented performance optimization for VDI environment, where we disabled some GPU-intensive features by default, like animations and Giphy auto start. We also have a guidance for non-persistent setup, like using profile caching solution and managing Teams cached content. From networking point of view, Microsoft Teams does not have any special requirements for VDI environment setup and has the same network configuration requirements as a regular Teams client. The full details can be found at aka.ms/Office 365 ports. But again, Teams on VDI has the same network requirements as a regular Teams client. I also included a link to Microsoft Teams network requirements in the end of this presentation. I always highly recommend to my customers to review Teams on VDI documentation and VDI partner documentation for details and best practices for each platform. For non-persistent VDI setup, we documented general best practices for performance optimizations for Teams in VDI environment. In non-persistent setup, users' local operating system changes are not retained after users log off. Such setups are common in shared multi-user sessions. For non-persistent setup, the Teams desktop app must be installed in per machine mode to the golden image. This ensures efficient launch of the Teams app during a user session. Using Teams with a non-persistent setup also requires a profile caching manager for efficient Teams runtime data sync. This ensures that appropriate user-specific information like user data, user profile, and settings are cached during the user session. There are a variety of caching manager solutions available. For example, FSLogix, Citrix Profile Manager, and VMware Dynamic Environment Manager will do the job for you. We highly recommend to consult your caching manager provider for specific configuration instructions. We also recommend to set up Teams cache content exclusion list for non-persistent setup. We recommend to exclude the folder app data /Microsoft/Teams from the Teams caching. This exclusion will help reduce the user caching size to further optimize your non-persistent setup. For platform-specific recommendations, again, please check platform partner documentation where they share more granular guidance. There are also several things that I want you to know, as these questions come up from customers pretty frequently. As I mentioned before, Teams network requirement equally apply to Teams on VDI as to regular Teams client. In order to get best audio-video experience and get optimized, you do need to deploy prerequisites. You do need to deploy required VDI partner software that has optimization enabled. It's very critical to your success. And you do need to deploy MSI version of Teams client. If you plan to run a web client version in a browser as a workaround, I just want to let you know that there is no optimization for this scenario, and you might not get good experience. So you do need to, for the best experience, you need to deploy VDI partner software that supports optimization and enable it and configure it and make sure that all ducks in a row. So there are some known feature limitations that we listed here, and we are working to shorten this list with future updates of Teams. So let's talk about supported VDI platforms. If you follow Teams on VDI topic, you probably know that we started with Chat Collab mode support. We released Teams MSI package solution focused on deployment and optimized performance on all VDI platforms in the first half of 2019. And then we released Teams Citrix VDI optimization solution in December 2019. A couple months ago, in May 2020, we released Teams on WVD media optimization to public preview, and we plan to release this feature to GA shortly. If you are interested, you can deploy WVD solution today. We also partnered with VMware and validating actively right now their solution in Teams Tab, and we expect GA release pretty soon. Now let's talk about specific platforms. Let's start with Windows Virtual Desktop, or WVD. As I mentioned, Teams optimization for WVD is in a public preview, and we plan to release it to GA soon. That means that you can download it today, right now, and deploy required software bits, configure it, and experience Teams optimization on WVD today. To get Teams optimization running in your WVD environment, you need to install Windows Desktop Client on Windows 10 or Windows 10 IoT Enterprise device. Then you need to install WVD WebSocket on VM host and enable Teams optimization via registry key. The VM host can be Windows 10 multi-session or Windows 10 Enterprise virtual machine. And on this slide, I listed current versions that are available in a public preview and support optimization. So let's look at architectural components on Azure WVD solution. So WVD VM on the right has Teams client and WebRTC components installed. When user launches Teams client on a host machine, the registry key is read that identifies that this is VDI mode, and Teams web services should engage and shim should be downloaded. Shim is a JavaScript in Teams that connects to the WebSocket and sends receive media commands to VM process WebSocket. WebSocket service then establishes connection between VM host and a client endpoint, and communicates events from VMware VM host to WVD client through the app service. There is also app service running on WVD client. On client machine, we have Teams VDI RTC plugin, which allocates audio-video devices which use in a peer-to-peer or conference calls. Here you can see a screenshot for Teams optimized in Windows Virtual Desktop VDI. Teams optimization for WVD supported on Windows 10. Audio, video, and screen share are supported with a single video stream for active speaker, and video resolution is at 720p. So now let's do a demo. So let me get my demo here. So basically you can see it's a Windows remote desktop. It's a WVD client. And I have Teams launched inside of WVD client. And the first thing I usually do is to check for a version. To check for version, you go to Profile Picture and About and Version. And when you do that, you'll see the version built, and also you will see that WVD media optimized. So it shows you that media optimized and which platform are you using. Another way to check if you run in optimized is to check devices under settings. And if you run in optimized, as we checked here, your devices will be enumerated and allocated properly, and they will show up under proper names. So in this case, I'm using Plantronics headset BT600. It's a Bluetooth dongle. So you can select Plantronics as your speaker and microphone. And also the camera is detected, and you see a nice preview of yourself before you join the meeting. So if you have multiple devices, again, you can select. I have 2 devices connected, so it's always fun, but it's there. You can select it and you can get preview. So now I'm going into calendar and I have a meeting scheduled. So I'm joining the meeting. So pretty much similar experience to what you have in regular Teams client. So you get pre-join experience. You can enable, disable video. You can mute, unmute yourself. You can select different device. Again, you can preview video. And if everything good, you can click join now and you join in the meeting. So in this meeting, I gather my peers, my teammates. As you can see, they all have video. The overall look and feel of client is pretty much the same. There is a couple things to note, that controls are slightly bigger and docked at the bottom in VDI implementation. And also the video is, it's a full screen single stream. So you can see that I have my preview, and then Lane was talking and I had full screen video. Then I asked Lane to share his screen. You see his screen, it's crystal clear. You can also see activity, and here you can see, as I mentioned, when I hover over a person avatar at the bottom on the tray, the contact card popped in, and you can notice that it's actually occlusion. So the contact card popped in on the back end, and we cut in a little opening to display that contact card. So that's occlusion. Now, again, Lane is sharing screen, and it's pretty responsive. It's fast. And now I asked Lane to stop screen sharing, and somebody else to start talking, so they become dominant speaker. And you can see pretty soon that it will switch to Dave. So now Dave is talking. We have his video, full screen, loud and clear, crystal clear picture. Now, with, again, the video switches with dominant active speaker. And I do have preview. I do see who's active, who's speaking. I see, so basically it's pretty much the same experience as in a Slim Core client. Now, you notice that at the bottom of the screen, the call controls are the same. You can start, stop video, you can do mute, you can share your screen. There are extra menu, and we'll go over that. You can raise your hand, you can switch to chat, you can change your devices. So it's all there, and video quality is very good. So now I decided to share my screen. So I select my screen, I had presentation open, and as you can see, there is over here, there is a red frame around my shared monitor that indicates that my monitor is being shared. So we have just a regular meeting, quality pretty good, and let me skip back to the meeting. So I also started recording, so all notifications that meeting is being recorded, that transcribing is started, it's all displayed. You can see that active speaker name is displayed. It's also actually occlusion, and I'm dismissing notifications. And then I check 3 dots. So what options available? So same options. You know, I can switch devices on the fly. I can go to full screen. I can go to meeting details. I can turn off incoming video. I can turn on a keypad if I need to do DTMF. So all that functionality is available in the meeting. And looks like I'm plan to stop screen sharing. So, and then I just hang up. I disconnected from meeting. So basically, that's meeting experience in Teams on VDI. So I included a screenshot from recording of the meeting just to show you and demonstrate the quality of the video stream. You see that my video bottom left is that's sourced from VDI session, and it's 720p, and you can see that it's actually very good quality. So let's talk about Citrix now. So VDI optimization for Citrix is available in GA since December 2019, and we see a lot of customers adopting Citrix customers adopting Teams optimization on Citrix VDI. So Citrix optimization solution architecture is similar to what I already covered with Azure WVD. The only difference, they have different names for services, but the fundamentals are the same. You know, Teams client detects that it runs in VDI environment, it loads JavaScript shim, and it loads WebRTC media stack. Shim connects to WebSocket service to communicate with Citrix Workspace app. Citrix Workspace app has WebRTC media stack loaded, and WebSocket service communicate both ways between VDI client and VMware host, VDI host. And audio, video, screen share media is processed and rendered locally and sent directly to other endpoint if it's an peer-to-peer call scenario, or it's sent directly to Office 365 conferencing service in the cloud. So what do you need to get Teams optimization running in your Citrix VDI environment? At a high level, I would recommend you to be on the latest and greatest software version for Citrix for backend and workspace app. Microsoft at Citrix, we continue a close partnership working on this solution, and we keep adding new features and functionality. In this slide, I include a screenshot for Teams optimizing Citrix VDI. Teams optimization is supported by Citrix Workspace app on Windows 7 and Windows 10. Audio video screen share are supported with a single video stream for active speaker, and video resolution is 720p. So I wanted to share a couple tips and tricks. So you've seen that when I started Teams on VDI, I checked that I'm running optimized, so I checked the version, and I was looking for VDI WVD Media Optimized, or whatever platform you're using, it will say Citrix Media Optimized. And the second indicator that you run in Teams Client Optimized mode is under Teams Devices section. If you are optimized, your devices will be properly enumerated and identified, and will be listed with proper headset name, or whatever device you're using, it will be proper name and not some generic audio device name. In this case, I was using a Plantronics headset, and it shows under devices as Plantronics. I also wanted to spend some time to cover support model for Teams on VDI. So the first step that I recommend is to get familiar with Microsoft Teams on VDI documentation, and then check partner documentation for detailed steps on deployment and troubleshooting. We spent a lot of time and effort to make sure that everything documented clearly, and it's easy to understand and deploy. And if you get into a situation where you need to get help and open support case, we advise to open support case with platform VDI provider first. If necessary, VDI platform provider can collaborate with Teams support team directly on your behalf if troubleshooting is required on Teams side. And I always recommend my customers to be prepared when opening support case and gather logs from VDI environment and Teams logs and include them when opening support case. Here is a list of useful links that I personally have open every day because I'm working on these validations. So they cover VDI-related topics I discussed. I recommend to start with Microsoft Teams documentation on VDI. It has detailed steps how to deploy and a list of certified VDI partners for Teams. Also, I included network advisory for Microsoft Teams. I included Citrix KB, how to deploy optimization for Teams in a Citrix environment. Also, there is documentation for WVD, and you can check that as well. And also included VMware blog where they're talking about where they announced that we're working on optimization on VMware, and you know what's next and what approach is. So with that, I would like to thank you for your attention and joining my session. I hope you find this content useful, and thank you very much.
That concludes this session. Thank you very much to Alex. If you would like to continue this conversation, if you have questions for him, please join our breakout area where he will be happy to answer additional questions. You can find the link to the breakout area in the Q&A. Thank you very much for joining.
Thank you.